So what you're looking at here are the four solutes that are listed on page. It's for lab number 14, part A. It's on page 163. It's that top table, and I have the four solutes listed here. I'm doing the experiment a little bit differently than is described in the lab manual, but it'll still illustrate the solubility trends here. Okay, so for the first set, what I've done, this is for the, we're going to add water to the different test tubes in just a second, and we'll see which ones will dissolve. So you can see potassium permanganate, iodine, sucrose, and vegetable oil. So the molecular formulas for potassium permanganate and iodine, of course, are listed. The molecular formula for sucrose is C12H22O11. Okay, so has some oxygens in there, and as of right now for our class, we know that those are going to be polar molecular compounds. So just to sort of anticipate what is going to happen here, since this is a polar solvent, then this polar molecular compound should dissolve in it. Sucrose, the more common name for it is table sugar. Okay, so we know, I think just from general experience, that table sugar dissolves in water. Okay, so that's one thing we can anticipate. Vegetable oil is very similar. It's not exactly the same. It's very similar to like a hydrocarbon. Okay, there's a lot of carbons and hydrogen there. It's primarily nonpolar. Okay, so we can kind of anticipate what the solubility trends are going to be for vegetable oil as well. Now I'm just going to simply, for this part, I'm just going to squirt some water into each test tube. And I think what you're going to be able to see pretty clearly, like in the first two, both the potassium permanganate and iodine, they're solid, they're purple solids. Okay, so we see the potassium permanganate has clearly dissolved in the water, produce a really pretty purple solution. Iodine, however, is not. Okay, so what that's telling us is that the iodine is a nonpolar solute, right? Water is polar. If it dissolves, like dissolves like, right? So a polar solvent has a tendency to dissolve either a polar solvent, a solute, or in this case, potassium permanganate, that's a salt. So ionic substances will tend to dissolve in water. Iodine, and this goes for really any of the diatomics, they are nonpolar. And so we're seeing that it's not going to dissolve in the polar water solvent. And then just to finish off this part, again, we kind of know what table sugar does. Now I've added a pretty generous amount of the sugar, and we can see that some of it has definitely dissolved in the sample. If we wait a little bit longer, I think the rest of that would dissolve as well. And then the last one for this part, I think what you can see is there is an emulsion forming. There's two layers. Well, the emulsion is where two layers are sort of coming together there. And if I hold it up there, you can see that actually it's the water layer that's on the bottom there. Water is more dense than the vegetable oil. Right? So again, that suggests that, well, vegetable oil is a nonpolar solvent or solute. And then for the other part of part A, that's where we have the same solutes. And now I'm going to put cyclohexane in each sample. Cyclohexane actually smells a little bit like gasoline. It is a very common organic solvent. You can see it's just a clear and colorless solvent. Notice that the iodine did turn a purple color. That's suggesting that, well, that's telling us it is dissolving in the cyclohexane just a little bit. So that shows us that iodine is a nonpolar solute. And let's see if we can get a better picture of some of these. Okay, so potassium permanganate, it's not dissolving. We can see the iodine is dissolving. Remember, iodine is a purple solid. You can see it there. Now for the sucrose, that is not dissolving at all. And no matter how long we wait, that solid is not going to disperse into the solution. Now if I look at the vegetable oil, notice that there's no distinct layer there. Vegetable oil is dissolving into the cyclohexane solvent. So that tells us what we kind of already know, that the vegetable oil is a nonpolar substance.